Who's talking shit?
Man, right when I hit record, dude.
God damn it.
All right. Is the following. That's how the video is going to start. It's Angel saying. Is the following 1-to-1? What's related to it? Okay. So part one is just find out if it's 1-to-1. And then part two, we'll compare this function to its inverse and ask you, are they, or which one is the graph of the inverse? So knowing the idea is a 1-to-1, can you find those graphs? Well, first of all, is it 1-to-1? Sorry, yeah, that's cute. If you were to graph it, do you remember what type of graph that is or what it looks like? No? Remember the mother functions? It's not a very good graph. I don't like it.
Yep, you're in trouble now.
So Mike,
Hey, Jack.
well, let me pause it before we get in trouble here. Record, huh? So the OG function, x cubed,
The OG.
right there. If you do +4, you're just going to shift this guy up 4. That's all it is. Okay, so if you remember the parent, +4 is just a vertical shift. But if they look the same, it just moved around. You should be able to tell by looking at it. Is it 1-to-1?
Yes.
Right, it's the first thing you check is it a function? You do vertical lines,
Yeah, right, it is, right?
so for sure a function. But then you do horizontal, if it is a function, if it only hits once, then yes, 1-to-1.
It is, right?
Yeah. So you just say yes by
I know, hope so. Huh?
the horizontal line test. F of x is 1-to-1. All right. Now, do you remember what the inverses look like? Like they're mirrored across the diagonal. Do you remember that? Yeah, like if you drew a horizontal line through the center, you just mirror it over. It's kind of like you're folding the paper.
I still can't get it right.
It's
Oh, we don't.
it's the Dyslexia, is that what it is?
I guess so. You're the real big, you know, something wrong today.
What, today?
Yes, I work. I retail. I was switching my numbers around all day today.
Oh, man.
Oh, like your total is $91 and some change. I'm sorry, what? I'm sorry, $19. $19.
Dang, imagine. I would be the one up there that might.
Yeah, I notice it happens more when you're tired. Or just not well rested. At least happens to me. I do the same thing. Okay. So notice this guy on C, right? All the X and Y values are swapped. So if you were to look at the X over here, look at a 0, 4. I'm sorry, 4, 0. See, I'm doing it right now. 0, 4. 4 zeros down here. So they're swapped, right? So that's already enough evidence to show you that this is the inverse is right down the middle. And it's mirrored across the diagonal. Okay. So you would choose C as the inverse function. Okay, so they have a couple of choices here. But you want to choose the one that's reflected off the middle.
Middle line.
Yeah, just 45-degree little line there. Okay. All right. But yeah, that's pretty much it for number 1. Let's look at 2. Number 2, legit just graph the function. So just match up the correct graph. You remember what the minus does to any function. What does it do to the graph itself? Do you remember? Yeah, it's gonna flip it down, right? What does a +2 do?
It goes down.
Goes up. So this flips it down, this moves it up 2. So if you remember what the original looks like, you can kind of figure it out. Because the original something like this. Okay. So if we do a -3, this will just flip downward. Do +2, it'll just move up. So just picture. Where the hell is it? Just picture this guy moved over here and then pointing down. So on the multiple choice, you just choose that one. That's it. That makes sense. Let's use a nice, pretty graph, right?
If it says what?
Um,
This is my answer, but if it says what?
This is the original. This is the parent function. So use this, assuming you don't have a graphing calculator. You can figure it out without it, because we should know what this looks like, just a general exponential, right? They all have this kind of shape. So minus negative in front, flip it down, +2 will shift it up. And we'll show you that in just a moment. Put that back in a sec. If I don't share it, Angel can't see it. All right, so here's the original. So it's basically what I just drew, except way prettier, right? Now, you put a minus in front of the 3. See how it just points down. That's it. So pick the one that looks like the blue one on your multiple choice. If you add the +2, well, it's gonna just move upward 2, but still the same shape. That makes sense? So the multiple choice. So here's the question. Sketches on your paper by using the parent function ideas. Okay, so which one is it? Is it this one? If the dotted line is the parent, choose the correct one. Right, looks like D, right? You could graph it on your calculator and just choose the right answer if you want, but the idea is to use the concept of parent functions and remembering what transforms them. Okay. So you don't need a graph calculator, but if you have one, I'm not going to give you crap. It's up to you. Any questions on 2? There's not really much to do. Just graph it. Okay. Write the following in log form. This is the definition. Okay, let me switch back. Yeah. Question? That you didn't have a question? Okay. Sorry, I didn't hear. You guys cool on this page, right?
That's the last day of school
Or
today.
maybe today.
It's the last class. I didn't see you. Okay. So next semester.
The following expressions.
Maybe I'll have to repeat the class next.
All right. So write the following expression in logarithmic form. So just use the definition that I gave you. So last time? Or the class before that?
What?
So use the definition. That's all you're doing. Use definition. There's no work involved. Definition says that this is the base. So you put log base 32. The argument is what it's equal to, the 2. And the power is what this one's equal to. Yeah, that 1/5. So just have a formula sheet with the definition, and you'll know to go from here to here or from here to there. Okay. So just make sure you have your definition. So you can change it from exponential form or change it from logarithmic to exponential. You should be able to go back and forth. That's right. There's not much else to say. Does that make sense? Is that cool? All right. So let me know. Number 4 is going the other direction. Write the following in exponential form. Log base 7 of 343 equal to 3. So definition says from your notes, the base 7 is going to be the base of the exponential. The power will be whatever this is equal to. And this will be equal to this argument. That okay? I don't have the definition on me, but something like, here's a random one from the internet. E to the x equal to y is the same as log b of y equal to x. I give you maybe slightly different on your notes. Maybe the same, I don't remember. All right. The first 4 not too bad, right? It's definitions and graph some stuff. Number 5, you're going to start actually doing work. Solve the exponential. Solve the exponential equation. So 5, 4x plus 1, 5 to the 4x plus 1 equal to 25. So I gave you 2 techniques to solve them. If you can match the bases, you can set it up pretty quick, or you can just introduce the logs whenever you want and bring the powers down. Okay, so we're solving for this x that's trapped up top. So I'm gonna do it the way that always works. That way you don't have to worry about it. Just learn this one way. If the exponential piece is isolated, which it is in this case, 5 to the 4x plus 1 is by itself. So just introduce whatever log you want. I choose ln because it's my favorite. The first step. Introduce logs. And then take advantage of all the log properties. It's the only reason we did that. So now I can bring down the 4x plus 1 in front of the ln 5. Okay. Trying to think if there's an easy way for you. That's fine. We'll distribute the ln 5 onto both pieces. So just distribute like this. Subtract the ln 5. Divide by 4 and ln 5. These are both just numbers, right? 4 times x times ln 5. I'll do in the next step. Next step. That makes sense, the way I did that. Canceling the 4, canceling this ln 5. So x is just weirdo number. There was a slightly easier way, but we did it this way because this approach will be used for the harder ones. Okay. Now punch this into your calculator. Is it 1/4? This is a fancy way to write 1/4. It is, right? You see it? Real? Can't see? Okay. Staring off into space.
No.
All right. You have a difference of logarithms. You remember that you can divide them, right? Well, 25 divided by 5 is ln 5, correct? From here to here, the top part was the quotient rule. Now notice that these are the same. You see how this is a 4th? Could have punched this whole thing into your calculator and gotten 0.25. You will. The multiple choice answer though is this guy.
What was I supposed to get?
0.25. Put parentheses. Put parentheses for the top. Yeah.
Oh.
All right, from the top. So first step to solve exponential equation, introduce logs on both sides, any log of your choosing. Then use the log properties. So I brought down 4x plus 1 in front. Now the goal is to solve for x using algebra, any algebra property, right? Just basic algebra. So I distribute ln 5 here. Got these two. Subtract this guy over there. And then divided this garbage on both sides here. Once that's done, we have solved for x. X is just this, which is 1/4. And you can do the actual algebra, or you can use your calculator, jump from here to here. Doesn't matter. Any questions on 5? You didn't get 0.25? All right. No questions on 5. Yeah. 6. Solve the exponential equation. Three to the x squared minus 63 equals 9 to the x. So here's the alternate method for solving exponential. The other one was for any type. On this one, it actually might be better to use this. If a to the x is equal to b to the y, then x is equal to y. This is a double implication logical statement, goes this way and the other way, bidirectional. So you could also say if x is equal to y, then
If X equals Y, then it's 56.
what do I say? If then that? What's your question? The purpose of the statement? The reason, we're creating a logical argument. That's what this is. It's an argument that can be proven with logic to be true. So this is a true statement. Once you make a true statement, then you can use it to your advantage. We have to put stipulations. For example, A must be greater than 0. A and B cannot be 1. Given those restrictions, yes, always true. Like read a contract, right? They're very specific. You just sign it and it sounds good. I just have a lawyer read it for you because they can be strange. Unless if you're not comfortable with logical arguments, have someone else read it to you or translate it.
Mr. Gonzalez, please don't talk to my client that way, sir.
Yeah, exactly. There you go. You gotta have someone backing you up, you know? Okay. So I'm rewriting the 9 as a 3 squared. So 3x, 3 squared to the x. If you have power to a power, do you agree that this becomes 3 to the 2x? Right? Okay, so now we're there, we can use the statements above. These are equal. Same basis as, oh, I made a mistake. This should be A. My bad. There is no B. Made it up. Kind of like a precedent, right? Legal precedent. Precedent.
Oh, the president.
Precedent. No, not president. Precedent.
What?
Not president. Precedent.
Not president of the United States?
No, like legal precedent. So different. Okay. Never mind. So these bases are here. So basically, like if a court rules on something, and that similar case pops up, you can cite that case because there's
It's
now
like saying
precedent.
before. It's like saying the word before.
Yeah.
Or previous.
Why not just say that?
It's not exactly the same. It's specific. So you're citing old cases. So that it's almost like it becomes a new law. So because this was ruled on, then if any cases appear similar to, your lawyer can quote them, cite them. and win the case. So we're citing these things. So we're building, I mean, since grade school, right? We've been building upon all these math topics and we're citing all of them in our problems. That's all it is. Logical statements. So using those statements above, what happens next? Yeah. All right. So we have a quadratic, so solve the quadratic you always have. All right. Does this factor pretty? I don't know. I can't tell. Can you think of numbers or factors of 63 that add up to -2, -63? Yeah. That's right. If you add them up, you get -2, right? Set each one to 0. And that's it. So you would choose A, the one that has both of these. So you will show me your work on how to get there. You can use this method if you can match the bases. If it's impossible, then you have to introduce logs. There's no other way. Okay. But if you see right away, like on the beginning of this question, you see how a 3 and a 9 are pretty similar, right? That's like a big hint. Oh, I should probably change this to a 3. Okay, that was the logic in this question. And then use this to help you. Once I've changed it, I can jump to this. Okay, that's only if you can change it. Any questions on number 6? Is that okay? Is it weird? All right. Turn the page in a sec. Yeah, so I'm rewriting the 9 as a 3 squared. Once I do so, these powers will multiply out into 2x. So now I have the same base, which allows you to set the powers equal to each other. And then you can just solve for x. So I'm able to use this one, the first one. Mhm.
Since it's squared versus x, so there was like so what if it was like x plus one, but I add that one to the two to get.
You would multiply times both of them. It'd be 2x plus 2. Okay. Seven is similar, so let's move on because not only so much time. Number 8. Rate starts with log equation. This starts off pretty easy. You need to get the x out of the ln, so you got to cancel ln. But in order to do so, it needs to be isolated. That 5 is in the way, so get rid of the 5 first. So first step. Let's divide it out. At this point, introduce a log that matches the base. What is the base of ln? A good guess, but no. But what does ln cancel? Do you remember? ln is a shorthand for log base e. It means this. That's all. It's a special base we use all the time. So e is ln, which means ln cancels the exponential e to the x. You'll see it in chemistry, engineering, biology. If you're dealing with growth, bacterial growth, studying that kind of stuff, you will. Cancel ln using e. So introduces as your base and changes to powers. I'm using that statement on the other page. It says if you have an equation, then you can bring any power, any base you want, as long as it's not equal to 0 or 1. This is called the natural log. Use just a special number like pi. It's like two. Yeah, the common log is base 10. So if you like on the calculator, you see just the log button. It's base 10. Like square root is root 2. ln is base e. Which one? Huh?
4.
Yeah, e to the 4 is kind of like 2.17 to the 4th power, something like that. And it keeps going forever. It's just some number. But this is the exact number. If you want the decimal, they don't. Multiple choice is a, e to the 4th. They want this. Any questions on these steps? Change this.
Does it look up that in the base for that?
Yeah, so if this was a log base 2 of x, I would bring 2's in to cancel it. Yeah. So whatever base you have, that's the number you're gonna choose. Since it was ln, I chose e. Like this one. Log base 6. So how would I cancel this log? Right, earlier we used e because it was base e. What is our base here? Yeah, e6. So 6 is the base I'm introducing. That makes sense? These cancel, leaving you with 6x minus 1 equal to 36. And I'll just solve for x and that's it. Yeah. Solve for x, so add the 1 over, divide by 6. That's it. Any questions on number 9? It's not too bad. It's not weird. All right. We'll turn the page. You guys okay on page? Question 9 and 8. Good. Solve the following. Log equation. Well, let's skip to 11. It's the same thing. Log of 4x plus 3 plus log 5 equals log 19x plus 20. All right, so before you do anything, you have to combine the logs on both sides. This one's already good to go. This one has 2 logs, just combine it into 1. Do you remember what happens when you have addition? To get a single log on both sides is the first step. What do we do with that left-hand side? You remember? No? If it was a minus, it turns into that fraction. If it's plus, it was yeah, the product. So right here you get this guy times the 5. Okay, so that's the product rule that we used. You can go ahead and multiply that 5 out, that'll be 20x plus 12. Once you have a single log on both sides, how do you cancel?
Wow.
Oh, 15. I don't know. Nowhere.
Wait,
I don't know about all that. Okay, single log on both sides. So step 2. Cancel the log using a matching base. What's the base? So if I didn't write the base, what is it? If there's no base there, it's assumed to be 10. always. So bring in the 10. So they will cancel. And now you have a basic equation. Solve for x. I think it's 5, right? The only thing is when you solve a log equation, double check, is 5 okay? Will 5 cause negatives or 0 inside your logs? The very beginning. Oh, no, looks fine. 5s. We're good. Here. Let's take a break here. Come back at 4:25.
There's some more you need to.
Yes. So 13 through, I think maybe all of the rest are interest questions for the most part, or investment type. So suppose you deposited 8,904.56 into an investment account for 8 years at 4% compounded semi-annually. So as soon as you hear compounded a certain number of times per year, we use this formula.
So what if it says compounding continues?
Then we use a different formula. No, you won't have an N. Okay. So what is P? What is rate as a decimal?
0.04.
Okay. Time is always in years. And they gave us N is the number of times you compound per year. So we compounded semi-annually. Then just plug it in and you're good. The question is, I forgot to write it. What is the future value of the account? After 8 years. A is a future amount. Whatever that is. You guys get. Yeah, that's right. Mhm. Not too bad, right? Just know if you hear no serial number of compounded, use this one. If it says continuous, you use a different formula. Okay, we're gonna do one of those in a sec. In a second. You guys cool on 13? All right. See? 04 ED94. Oh, that's fine. It's you switch the 9 and the 0, 8,904. But you typed it in mostly right. You guys cool on this page? Okay. Suppose you are researching IRAs. To invest in your future. You save $9,000 and intend to invest it. After searching online, you find 3 banks. That offer the following. Bank A, 5% compounded annually. Bank B, 4.9% compounded daily.
Maybe as in
Every day.
day?
Mhm.
Okay, no.
Bank C. 4.85%. Compounded. Continuously. Means this guy here. You use this formula. There is no N, there's a E to the RT. These are both the same as before that we just did. So if you decided to invest your money for 35 years, at which bank would you earn the most money? Yeah, it's a very wordy question. I know C is best, assuming you're compounding forever, right? But I'm only doing 35 years. Will the higher rate get me more money in 35 years? Or will the continuous get me more money in 35 years? There's a point.
I guess it's B, because I said C.
Or will A
Instead of B, yeah.
work?
But it makes sense.
C only works if you keep it in there and don't touch it no matter what happens. It's only gonna compound continuously as if you just leave your money in there.
Look. You said that would work if I'm keeping it in there forever, but I chose 35 years.
I mean, we could graph all three of them and see
No, that's B.
Answer is B.
which one overtakes what and when.
Well, C overtakes B after 35 years if we're leaving it there forever.
There's, I don't know when, but there is a point where C wins.
But.
Does C win in 35?
years,
That's the question.
right?
I don't know if C wins in 35, might win later, might win before. Maybe A's faster if it's a short amount of time.
Yeah,
You're
it's
getting
only
the
one.
almost same amount every day.
It would be 35 years in total for all of them, you just see which one.
Which one gives me more money? Just plug in the numbers and so,
On something here.
so just, so I'll, on the actual test question, all you gotta do is just plug it in. Show me each one. Yes, it will be B.
Because it's data.
Are there banks that really do that?
Well, when you invest, the average return is about, at least for the last 10, 20 years, it's been like 6 to 10% return. So 4.85 is conservative. You'll probably get more. You deposit $50 every month when you're 18 till you retire, you should have a few $1,000,000 to retire with.
What bank is that?
That's with any IRA. And if you choose a Roth IRA, it'll be tax-free. So
A what?
that's Roth,
A rock?
Roth,
Rock.
ROTH. If you do open a retirement account, which you should as soon as possible, is open the Roth type.
So what you need is base.
Bank account. Pretty much a ID card, maybe. Some might want a initial deposit, but most are pretty chill nowadays. Just open it and put money whenever you want. But the idea is put it every month. If your bank has Roth accounts, then yeah, it just depends. Oh, for sure. Man. You say it's a good bank. Okay. If you want financial advice, you can message me some other time.
Oh.
All right, let's get to this. So just plug it in. That's all you got to do. So for bank A, let's see here, 0.05 over 1, right? To the 1 times 35. B. Everything's the same, just change the N. And the percent. Daily, should we say 365, I guess? Let's not get too technical. Okay. So punch each of these in your calculator. Which one's bigger? That's all you got to do on your test. Box the one that's bigger, choose it. Okay. There should be an E button above LN. That's for continuous. I messed that up. Oh, yes, I did. Okay. So the first one I got 49,000 644 14 cents. Second one I got 49. Oh, actually, sorry. 51. $51,785.22. C, which is the one we wanted to choose. $49,142. .0485. Like this, the E function is more powerful, but it needed more time given these rates. Okay. If we're gonna leave it there for 50 years, then yeah, I would have chosen this for sure. Right. It looks like it's getting close to matching both of them, right? So I don't know how many more years we'd have to do math to figure out what the breaking point is, but
So the percent was higher, like say it was the 5%, the other one was the lower one. That's what you choose, right?
oh, for sure, yeah.
So it's like 5%.
Yeah, the higher, because the percent,
5%.
yeah, the percent is the return you're getting every year, so with this type of growth, it'd be way faster at 5. So either more time or better rates. We'll do it for you. Yeah, you should. Mhm. I think the maximum you're allowed to put in per year is about 6,000. They don't let you go beyond that because it's too good of a deal.
It's what?
The Roth accounts, they don't allow you to put more than about 6K per year.
You don't.
No, because it's too good of a deal. You guys scroll on this page? Yeah, it's tax free. So when you retire and take it out, they can't tax it. It's your money. That's why Roths are nice. Okay. 15 is I don't think we need to do this. Let me show it to you. Here's 15. I think you guys can handle this on your own. Well, let's just find the present value. Would you be comfortable assuming you have the future value? So finding out what you started with, assuming you made 4,000. Or did you want to do this one? Do it? Okay. Alrighty, let's go ahead and do it. I won't make you write that much again, I hope. 15. Find the present value, which is the same as a principal. That will grow to 4,000. If the annual interest rate is 8.5%. Compounded quarterly for 10 years. These type of questions are good for situations where you want to know, I don't know, let's say you had an account or maybe like a CD or something, and you want to know, okay, how much do I need to put in to hit 4,000? Or like if you had a financial goal, like how much do I need to start with to hit 20K in 10 years or something like that? So that's basically what this type of question is. Okay, now the future formula is this one that we wrote down earlier. So if you solve for P, then you have the present value formula. P, the principal or present value is equal to A times 1 plus R over N to the negative NT. So I did the algebra for you. You'll end up with this. So use that formula, just plug it in, and you'll get principal. You don't have to do any work. All right, so what is A? Okay, what is rate? As a decimal? What does percent mean? Right, we use it all every day, all the time. What is it?
We do.
Don't you?
What did I ask you? What is percent? Angel.
Like you have 50% off, 40% increase, 30% chance of rain. What is percent?
That's how much. That like. Green, I guess. And what, and the rain. That's unlikely would have been happening.
Yeah, it is a proportion.
My input is percent would most likely be as in a fixed rate where it's gonna be less than the present price, like he just said, like, oh, if you're gonna get 50% off, what does that really mean? So originally you buy an item for $100, 50% off would be $50, quote unquote, but you still have to pay tax after the $50, so it'd be like 57 or 56. So it's not true $50.
We're not talking about his tax.
It just means out of 100. So
Right, the number or amount. Each under. I don't know how to do this thing.
the symbol means this. So 20% means 20 out of 100. It's a corn. Oh, it's the first. Okay. Okay. But yeah, it's used for all kinds of things. What's time? What is N? Okay, we got everything, right? So what's principal?
7, 2, 4. We love you, Angel. That was awesome.
Angel tried.
No,
And there was good input.
Well, thank you. Or another thing about percents is what is the percentage of people reaching the age of 21 that people that grew up in the hood or people that grew up in an ugly area, the percentage of someone actually reaching the age of 21 is, staggering numbers among colored people and people that are Hispanic descent. So I would say the likelihood for some of us to hit the age of 21 would be, 63% versus, our other counterparts, don't even reach that age because of their life circumstances.
What's a counterpart?
Oh. Negative.
Okay. Or did I learn it? Not.
So you can have a negative sign. So what would that signify specifically?
The negative 40? What'd you say?
Oh, yeah, the negative would like. But kind of how you're thinking about the laws.
Oh,
Is there another way you can have negative to that?
yeah, there's a negative built in here. Because when you, well, think about it this way, right? If I want to solve for P, what would you do? Right, you'd have to divide this thing out, right? Divide both sides by 1 plus R over N, NT. So this would go on the bottom. So if I bring it to the top, it'd just be a negative power. If this thing is on the bottom, like let's say I divided this on the bottom of A, and I brought it to the top, right next to A, then it would change to a negative. That's why it looks like this. Do you see it or no?
Oh, okay, I see that there's.
Yeah, so I'm solving for for P using this.
Oh. I thought it was still A equals B, but you just adding the negative next year.
Yeah, yeah. If you solve for P, you'll end up with this by dividing 1 plus R over N to the NT on both sides. Oh, starting amount is. Then you put in 7. Yeah. Yep, that's it. So if you see anyone asking for principal or present value, use this one if they are talking about compounding a certain number of times, like non-continuous type. Okay.
What would be the one that was asking?
Yeah. So if they want future value, use this, right? For continuous compounding. If you solve for P, you would get A e to the negative RT present value for continuous compounding. Principal is it AL or LE? I forget. I don't know. Wait a bit. For 16. I don't think we need to work it out. Just look at this guy. So a sample of 300 grams of radioactive substance decays according to this function. So this exponential model, see how it has a negative power? For these type of models, negative power signifies decay. If it's a positive power, then it's going to be growth. Since they're talking about decay, it should be negative, and it is. And the question says, how much of the substance will be remaining after 10 years? So just plug in 10 into your calculator, and that's it. Nothing to do. The 300 right here for the model signifies the starting amount. So this is your 300 grams. This is the one that's, this function right here is making a decrease over time. T is time in years. So plug in 10. So that'll shrink down the 300 to 222. That's all you got to do. So you should understand, can you plug in a 10? Do you see what the function's doing? But the work itself is just, you know, calculator buttons. Any questions on 16? Okay. Okay, what does it say now? Okay, so they're testing soil, pH levels of soil. If the team has found on average their soil samples has this much hydronium, how should we classify the wetland? Okay. So you just look at the 5.62. Is it between the poor, moderate, or rich? Where's, yeah, it's in the middle, right? 5.62 is right there. That's all you have to think about. The 10 to negative 7 is just, it's a really small number. So the pH levels are like less than microliters. It's really tiny measurements. So these levels, they just remove the scientific notation here. They just want to see, okay, well, is it within this range? So this is their definition. Is it there, here, or there? Nothing crazy, right? The one in the homework that we did together, we had to plug stuff in and solve for things, but here, just read it. It's not as bad. Do you have any questions on 17? Do you see why it's moderate?
I don't just have to be able to use material probably still limited to the one.
You can use the printouts I gave you on like 2 pages front and back. Shouldn't need more than that. This guy, we need a formula. I gave it to you, and I think it was it last time or the day before, the time before that? Formula for hydronium concentration. It was like a log. Do you remember? I don't know if you might have not been here. That's right. You had, it's bad luck.
Yeah.
That's funny. It sounds like they're making fun of. What is it? Is it Herbalife?
Huh?
Question 19, I think it's kind of
Adolescents?
make fun of Herbalife or that type of model. Business
Organic
model?
fruit cheese,
No, the MLM.
herbalists.
It's a brand that sells supplements, vitamin supplements, protein powders,
What is it called?
Herbalife. Never heard of it?
Oh, yes, yes.
Yeah. Yeah, I think that's an MLM. The idea is you get 5 friends and then those friends get 5 friends, etc. But it's really a Ponzi scheme, a pyramid scheme. So if you're at the top of the pyramid, then yeah, you make millions, right? But since you're not at the top, you're way at the bottom. So you're earning money for the people above you. So it doesn't really work. That idea, any kind of Ponzi scheme, like if you hear anything like that, just stay away.
Yeah,
Don't do it.
there was a.
But anyway, if we pretend it was real, this model would tell you how much money you would make if you had 10 rounds of growth. Because the idea is that it's exponential. So in theory, it should bring tons of money, but it's a scam. So if you bring in 5 people and then those people bring in 5 again and again, that would be 5 to the 10th power. So just plug in 10 and that'd be the actual number. But of course, they're not all going to agree, and they're not going to have 9 million people below you, right? What's another one that does it? Yeah, that was like a close one. Remember? Yeah, I think that's another one type of thing. It's not going to get you the money you want. It's best to do something else. Those types of ideas. I don't recommend them. The math doesn't work out in your favor. But anyway.
Ashton, there's this show on Netflix called The Concrete Bridge. And there's a lady on there, but that's what, basically what you said, you know, the levels and stuff. Well, she got the car, she started out with like, she ended up with like 200 plus people on her team, and now she's part of that out. She ended up with like 50 people, and the deal was, I think she got like 11% interest rate on that car, which is like really nice, but she got a Cadillac. Right, and then when she didn't reach the goal, she had to pay the payment, which was like $600+, and her insurance wasn't included on that, so she only made $1,000 payments on this car because that job that she got into
Yeah,
was not working out.
she got screwed. There's a lot of horror stories of people put like their life savings into these things and then they get screwed.
I thought this was good interest rate.
Better off opening a taco truck. Okay, you can make money there, but yeah, like, you're better off doing if you have like some cash, like do something like that. Don't do MLM stuff. Number 20, same type of deal. You have a model, plug in your X and you'll get your estimate. This model measures population growth of some species. I don't really care what it is. Endangered species back from the brink of extinction. So some biologists made this model and this measured the growth over time. So 50 years, what size will this population be? Plug in 50. So this breeding program looks like you'll have 30 and 50 years. Maybe they're pandas. I don't know. Ever seen those red pandas? They're super cute, man. I totally want one. Although I think they're endangered and that's illegal. All right. That's it for review.
Honestly, for that last one that you're doing, and then that's floating for the X.
Mhm.
Oh,
Yeah, that's it. So just put in your calculator, plug in 50. It should simplify into 30. 30 of these creatures.
I forgot which species the bird it was, but there was a bird that basically brought it from back from extinction.
Really?
Like it's closest, like what is it, like just genetically like
Algebra.
running back. What the other one was.
Oh, like it changed into it? Oh, that's crazy.
Yeah.
That is weird. Wonder what would cause it to change.
And I thought it's more of a tropical bird. Closer to like the bigger areas, and then they tend to like migrate slightly more, and then that was a lot change.
Hmm.
I feel like it wasn't like 12 years, but
That sounds really interesting. I don't know what it is.
Oh my god. I never keep with you, not nice.
Okay. Let me give you some notes for the final. You don't have time to review the whole thing, but we've already talked about everything. Be 25 questions. Multiple choice. All right. So number one, going to be basically composition of functions. So review. Composition of functions. This is the whole fog and Goff. Review those things. Number two. Understand parent functions and their transformations. Able to solve quadratics with the square root property. Able to solve equations. Wrote that out weird. By squaring both sides.
So if you're not reading the word for the final, you just have it.
Right. Able to find the domain. and range of square root functions. Be able to plug in values. Into functions. Sorry, what's up? Hmm? Quadratics with square root property. You guys looking at red pandas?
No, not really. Originally, I was so the combination of okay.
Given the parent and a transformed function, understand how that affects the graph. Is it fx or fx? Fx. Always forget. Okay. Number 8, be able to solve rational equations. Find the vertex of a parabola. Be able to graph a rational function. Given a graph, be able to find the intervals where it is increasing, decreasing, constant. Find the axis of symmetry. Of a parabola. No way, because my hand hurts.
My psychology class. One teacher said, "Oh, you're gonna go and study with these." It's not. So she has like 1 to 25. She's writing like this, not to everything. And he's like, "Can you write that on the board?" Can you write it? No, not really. So funny. So like each question.
Yeah, I'm helping you out right now. Take advantage. Understand degrees. Turning points. Zeros. For polynomials. Yeah. But I'm not gonna do it in Canvas. I'm gonna do it in my Excel file. So you won't see that reflected. So your actual grade will be higher. So if you see your grade in Canvas, it's like a 75, but I haven't replaced it, then it should go higher. Should be like an 80 or whatever, depending on what you do. No, I'm turning the page. You guys cool? No worries.
And the ones from the orientation. Those ones like those are like they're missing initials,
Oh.
like still missing it's from the orientation.
Yeah, orientation is not part of your grade. It was just to see if you do the bare minimum to start the class. That's all.
Some of mine aren't updated to the right ones, like the resource.
Like they haven't synced.
Yeah.
Yeah, I'll check.
I have to look at because this was yesterday and I was doing them this.
I know it should take, usually takes maybe 5-10 minutes, but if it's not, if it still hasn't updated in Canvas, like if my labs says 100 and Canvas says it's just a blank, let me know. Either way, I'll be checking that when I start grading everything, or when I'm done grading. Practice tests are homework grades. Okay. 14. Understand and behavior. Be able to solve a 2x2 matrix. Something like this. It's Kimberly's favorite. Be able to find vertical and horizontal asymptotes. Be able to solve exponential equations. Be able to solve log equations.
Said all of, a lot of.
18, 19 the same. use the pH formula. Which was actually little p capital H equal to negative log of the hydronium just plug it in there. If they give you hydronium, you plug it in, then you'll get the pH. If they give you pH, well, you plug it in here and then solve for hydronium. So you'd have to cancel the log. You know what I'm saying? So it could be one of those two scenarios.
That is a negative log.
Yeah, this is the actual formula, just like that. Be able to solve for future and present value. For the interest formulas. Able to use the decay function. Oh, sorry. So from the last review, remember I said, here's this thing that models decay, plug in a number. We just did it like 10 minutes ago. That's what I'm saying on 22. Exam 5 review. We did this one of these. Change a set of equations, or I guess we should say the correct word. Change a system of equations into an augmented matrix. Be able to see what the first row operation could be for a matrix. Given two rates and two prices, calculate the best deal. Using the given information. I think you two scenarios. You just figure out what's the best deal. That's all. The money problem. That's it. There is a final review in there. Recommend practicing it a couple times. Go over anything on this list that you don't remember. And let me know if you need anything, if you get stuck. Okay. Guys have any questions?
What's 19?
Can you get the answers to all of these?
What's 19?
19 is the same as 18.
Can we go to- right?
They're the same thing.
So you can just-
They're giving you more than I usually give. Okay. Well, that's it for today. And the thing here.